So hey Lauren, Mike Smutak here, Uxbridge High School up in Massachusetts. And what I did is I took a look at this. I'm I'm by no means a professional machinist. I pretty much learned how to do this by teaching sim and breaking a lot of tools and a lot of messed up parts. But here's a little bit about what I tried to do here. So I left your setups and everything in there. I just made my own new one here. Left your Haas mill. First thing I'm doing here as I'm looking at this, I'm looking at a couple of things. First, you've got a pocket that's sort of on top here. Then you've got a series, it looks like a series of holes and then a series of slots in between them. So that's sort of a little bit of how I broke this down. Um, and I can go through it toolpath by toolpath with you. So what I have here is my um, adaptive toolpath with tool number 4, quarter-inch flat. I didn't know if it's exactly from, it is not exactly from Project Lead the Way's tool library. You can set up your tool library however you want. Just make sure you have enough flutes on your bit and enough stick out to make sure that you can get down into the areas where you want to machine. So I did not mess with speeds and feeds. I simply messed with the geometry a little bit. Because it was difficult for me to choose this bottom pocket, I chose this as my pocket selection. And then I came over to my heights tab and I chose my bottom height as that face. So when you're having trouble finding pockets, sometimes that is an option that you can use, is to define the geometry at the top and then choose a different bottom. I like to use adaptives a lot because they are easier on your tools. With a pocketing toolpath, what you can find is a lot of the tool is engaged in the corner and it breaks tools. I have no idea what machine, or I know what machine, I don't know what material you're going to machine this out of. So I left your speeds and feeds and everything alone. As far as passes, I like to use tool diameter times 20%. So my maximum optimal load here is going to be 20% of whatever tool diameter I have. For this application, it's a quarter-inch end mill. For some of the others, they may be larger, they may be smaller. I did use multiple depths because I want to make sure that I don't break anything. I turned on smoothing. It just seems to make makes your tool paths a little bit shorter, so your processing time's a little bit less sometimes. And I don't think I messed with linking at all. I just hit OK. And the thing with these strategies is I hit OK multiple times, didn't like what I saw, tried something else. Went back, changed one thing, tried something else. Next thing I went through is I noticed you've got all these holes. Well, that's a perfect operation to use. That's a perfect time to use my drilling operation. These are 1/8 inch diameter holes. I don't know if you want the bottom to be flat or not. That may be an issue. We may have to go back later with a 1/8 inch end mill and just clean up the bottom of the holes or something. But I used a drilling tool path with an 1/8 of an inch drill bit. Again, I don't know your machine, so I didn't mess with speeds and feeds. For geometry, I selected a hole face, and then I did select same diameter and just picked them all. Heights I left alone, but under cycle here, this is important. With something that's so small, it's important that you do some sort of pecking or retracting as you go, so that you don't clog up the flutes of the drill bit with whatever material you're machining here. So I chose deep drilling with a pecking depth of a 1/16 of an inch. And what that means is this will drill down a 1/16 of an inch and then raise itself back up and then go down another 1/16 and raise itself up to kind of clear the chips out. Again, I've had pretty good luck with drilling round things first. You get an exact perfect diameter. It's a little bit easier on your end mills when you've got this material removed already, so there's like space for chips to go. So there's my drilling tool path. And then the last thing here is your really skinny, and I didn't do it to every single slot, I only did it to this one here so far, is I made a tool 16th inch flat end mill. I made sure that my tool in my tool library is physically long enough to stick out. I think it's in, nope, it's over here, it's in cutter. I made sure that my length below the holder, which is from where your tool holder is to the bottom of your tool, I made sure that that was sticking out enough that the tool holder wouldn't hit the sides of the part. So I think I may have had to make a little change on there. This is a 16th inch flat end mill. My advice is to buy like a dozen of them. Don't buy like one or two because they're going to break. That's just been my experience. Maybe I'm a terrible machinist, and that's okay. I'm learning as I go. So I'll hit accept on that, and my computer will freeze. Oh, here we go. So I used a slotting toolpath here, 2D slots, and my geometry, I just chose sort of your pocket selections. And what I had to do to get to that point was I came over here to models, and I turned on this sketch. So I made that sketch visible. So what I can also do is I can come in here and I can select more of them. And that I may have had to go through and mess with my depths as well, just like I showed you previously with this first adaptive for this first big pocket here. So there's my slot. I'm not getting any computing errors here. So let's just take a look, see how the whole thing looks when we go together here. Let me turn this off, and let's see what this looks like. Oh, multiple tools program without enabling properly allow multiple tools. That may be a Haas thing. I'm not sure. Not seen that before. So I'll just come here and click tool isometric, and we'll hit play here. So this is going to go, I'm fast forwarding because it's a little bit of a longer tool path here. It's going to take this out in 2 passes. I can certainly turn my tool paths kind of off here so we only see a little bit of it. And I'll send you this F3D file too, so you can play around with this. There's my drilling. I wanted to slow this down to let you see that it's actually taking little pecks of the holes to clear out the chips. So that's what that does. And then we'll see how it does its slotting. Remember, I had to mess with the tool a little bit to make sure I had clearance in there. So there's the start of it. I would keep going with this. You're at about 39 minutes as of this point, but that's based on speeds and feeds, which I have no idea about. So good luck, and please reach out and let us see the final product here. Please reach out if you have any more questions as well. Thank you.